we've been looking at solving rational expressions, and there's a kind of a big part of it we've just ignored up until now. So so what if I had, so let's simplify this. How would you simplify the numerator? Colette, you might want to pay attention. We're going to pull out a 4x in the top. What am I left with? Minus 4. Okay, in the bottom. Braden said, hey, I have an x minus 4 on top. I'll probably have one in the bottom. In this case, he's right. So these cancel, and I'm left with 4x over x minus 1. Okay? Now, that is the simplified version. If you look at your worksheet, and thanks for making a mess, the first 6 problems are super easy. It says state the excluded values for each. If we were to treat this as a function, are there any numbers we're not allowed to plug in? Well, there are only 2 ways to ruin real numbers. How are they? Divide by, well, there's only 2 ways to use real numbers to get non-real numbers. Multiplying by infinity doesn't count because it's not a real number. So you either divide by 0 or you square root a negative number. Now, square rooting negative numbers is not going to happen today because everything we deal with is a polynomial. And polynomials have whole number exponents, x to the first, x squared, x to the third. So today, we don't have to worry about that. All we have to worry about is dividing by 0. So if we go back to the original function, what makes this 0? Well, if you plug in 0, 0 minus 0 plus 4 is okay. That number would work. Well, we find the roots. Find the roots of the denominator, which I've already factored them, so I'm halfway there. Set these equal to 0, and x is not allowed to be 4 or 1. Now, if I plug those in, 1 minus 5 plus 4 equals 0, and whatever happened on top, whatever that number is divided by 0 is a non-real number. It's actually infinity. Okay? If I plug in 4, 16 minus 20 plus 4 is also 0, and no matter what happens on top, anything divided by 0 is infinity. So these 2 numbers are not part of the domain. Those are 2 numbers that I plug in and I don't get an answer out. Now the interesting thing is, if we were to graph it, different things happen at those 2 numbers. Okay, at one of them, we end up with something like this. Well, it's probably not that. It's probably like this. So here's 1, and here's 4. At 1, we get something that looks like this. In which case, there is no x equals 1 on that graph. Okay? And at 4, we get what's called a hole, which is the graph's just moving along, jumps over 4, and then continues on. So 3.9999999 is there, and 4.0000001 is also there, but the number 4 is just blank. So this function is not what we call continuous. There's no way to draw this function without lifting your pencil, because it has 2 discontinuities, one at 1 and one at 4. Okay? So on the first couple problems, all you're doing is figuring out which values for x or v or m make the denominator 0. Well, what if my denominator looked like this? Jason will get it eventually. So if I set this equal to 0, I get x squared equals -4. When does the graph cross the x-axis? 2i, and at -2i. And if you remember, if you take, let's say you had 5 plus or minus 3i, okay, and then you were to erase the I and do 5 plus or minus 3, that would be 8 and 2. So I would take the graph at 2 and at 8 upside down. And then this graph would be the mirror image of that at the vertex. So that's, yeah. And it all depends. It depends on your leading coefficient. If your leading coefficient was a 2, that would make this graph thinner, which would make this graph higher. Because if you know the roots, you have no idea how wide the parabola is, because they're an infinite number. You'll know the line of symmetry, yes. But the vertex depends on the leading coefficient. So if you know the leading coefficient and you know the roots, then you can graph it without a calculator. Because you can find what the roots would be if there was no I, and then take the vertex and invert the parabola. And that always works. So this one is continuous everywhere because there's no way using real numbers to make the denominator 0. Okay? The rest of the first page is just similar to what we did last week. If you turn it over, look at number 15. They've done us a huge favor on 15. They've already factored it for us. So I have one rational expression divided by another rational expression. How do you divide two fractions? Flipping times. So it's really v minus 10 over 1. And this cancels that. So these cancel. Yeah. Okay. Look at number 19. So I need to flip this, b plus 5 and b minus 6, and then you need to factor that. Okay, and then they'll simplify. Look at 23. You're going to flip the second one and factor. Right? But on 25, you don't need to. You're just going to factor. And anything on top, once you have the division flipped upside down, so on number 23, once you invert this, and then you factor, anything on top can cancel anything on bottom. So we'd end up with 1 over 5p squared, and on top we would have 5p squared times... No, never flip the first one, because your answer will be upside down. So if you did 1/2 divided by 1/3, you're going to flip 3 over 1, and you get 3/2. But if you flip the other side, 2 over 1 times 3 over 1, oops, I didn't flip. Yeah, sorry. 1 over 3 is 2/3. No. So you always flip, you flip the large denominator, the second half. Right. Okay. So on 23, I'm going to pull out a 5p squared, and I get p minus 7 over, I'm going to pull out a 9 times p minus 4. Anything on top can cancel anything on bottom. The only things that cancel are the 5p squareds. So p minus 7. And my guess is on the answer sheet they leave it like that, but that's not how the ACT will have it. You need to put it back in. So it really didn't do us any good to factor that one because it didn't cancel. On 25, don't flip anything. It's a multiplication problem already. So just factor the top, factor the bottom. What if I had negative x plus 4 and I had x minus 4? Does anything cancel? Are they the same factors? They're really close. Right. So can I adapt this so that it will cancel? I can pull a negative 1 out of either one. It doesn't matter. Which one is easier to take a negative out of? So pull out a negative 1, and what am I left with? X minus 4 over x minus 4. Those cancel, and my answer would be negative 1. And that's a trick that you'll see every once in a while. In general, if the leading coefficient is negative, you want to pull it out. Okay? Any other questions? Hang on. Okay, I'll put up the answers.